Advanced Driver Assistance Systems, ADAS, refer to a set of technologies designed to enhance vehicle safety and improve the driving experience by providing assistance to the driver in various aspects of driving. These systems use sensors, cameras, radar, LiDAR, and other technologies to collect data about the vehicle's surroundings and the driver's actions, and then use this data to make driving decisions or provide warnings to the driver. Here are some common ADAS features and how they work. Adaptive Cruise Control, ACC. This system maintains a safe following distance from the vehicle ahead by automatically adjusting the vehicle's speed. It uses radar or LiDAR sensors to detect the distance and relative speed of the vehicles in front. Lane Departure Warning, LDW, and Lane Keeping Assist, LKA, LDW alerts the driver when the vehicle unintentionally drifts out of its lane. LKA goes a step further by gently steering the vehicle back into the lane if the driver doesn't respond to the warning. Automatic Emergency Braking, AEB. AEB detects an imminent collision with another vehicle or obstacle and automatically applies the brakes to prevent or mitigate the collision. This feature typically uses sensors to monitor the road ahead. Blind Spot Detection, BSD. This system alerts the driver when there's a vehicle in the blind spot, typically through visual or audible warnings. It uses sensors, often located on the sides or rear of the vehicle. Parking Assistance. Some vehicles have automated parking systems that help drivers parallel park or maneuver into tight parking spaces. These systems use sensors to measure the available space and control the steering while the driver controls the throttle and brake. Traffic Sign Recognition. Cameras or sensors can detect and read road signs such as speed limits, stop signs, and no entry signs. The system then displays this information to the driver on the dashboard or head-up display. Collision Avoidance System. This system goes beyond automatic emergency braking by not only applying the brakes but also steering or accelerating the vehicle to avoid a collision if the driver doesn't respond to warnings. Driver Monitoring System. This system monitors the driver's behavior and attention level. It can detect signs of drowsiness or distraction and issue warnings to keep the driver engaged. ADAS technologies work by combining data from various sensors and processing it using complex algorithms. For example, radar sensors can measure the distance and speed of nearby vehicles, cameras can identify lane markings and road signs, and LiDAR can create detailed 3D maps of the surroundings. The onboard computer processes this data in real time to make informed decisions, such as adjusting speed, steering, or applying brakes when necessary. It's important to note that while ADAS systems offer significant benefits in terms of safety and convenience, they are not fully autonomous systems. Drivers are still required to remain attentive and engaged while using these features, as they are meant to assist rather than replace human driving skills.